Hello everybody, this video is going to be a continuation of our Le Chatelier's lecture. You should have a worksheet like this that has 8 chemical equations on it. We are going to decide how we're going to stress a reaction out. Based on that stressor, we're going to decide if the reaction will proceed to the left or to the right, and then we'll write down all the various changes that we expect to see based on that shift. So you have to be told what the stressor is. If you're just given a chemical equation, there's nothing happening, right? The stressor is something that we are doing. So I'm going to tell you, let's zoom in a little bit first. For problem number 1, what we are going to do to stress this out is we are going to increase the concentration of nitrogen gas. So what we are doing here is we're increasing a reactant. We're increasing something that's on the left side. Well, if I now have too much nitrogen, I'm going to proceed to the right to try to use it up. So my reaction is going to shift to the right. Now the changes that are going to occur, we're going to list what the changes are for every single chemical. I suggest that we do the stressor at the end because it's usually the more complicated one. So let's start with nitrogen monoxide. If this reaction proceeds towards the right, in order to use up some of this nitrogen, it's going to be making more nitrogen monoxide in the process. So the concentration of this, when we get to our new equilibrium point, is going to have increased from where we started. Let's look at how the concentration of oxygen gas changes. Well, if I'm proceeding to the right, going in the forward direction, I'm going to use up some of this oxygen. So when we get to our new equilibrium point, our concentration of oxygen is going to have decreased from where we started. Now for the stressor one, the one that's a little bit more tricky. If you remember from our lecture, I showed you like a little graphic that helped us walk through this. So before we start, we're at this level. I added nitrogen, so I went way up here. This is during the stress. The reaction is going to shift. It's going to come back down, but it can't come all the way. So this is the after. Compared to where I started, there is a slight increase. Not a ton, just a little bit. We can't get all the way back down there, but it's better than when we had messed it up. All right, let's do the next one. This time, for this equation, let's increase the concentration of our hydrogen iodide. If you notice, this is increasing something that's on the product side, right? Well, I want to use up all this extra, so I need to proceed to the left. I need the backwards reaction to happen, right? So we're going to take some of this and break it back apart so that we have less than we just dumped into the beaker, right? We're going to use some of it up. So we're going to shift or proceed to the left. Now let's look at how each of our things change. If I proceed in the backwards direction, I'm going to be making more hydrogen. So the hydrogen concentration goes up. Same with our concentration of iodine, right? We're going in the backwards direction. We're shifting to the left. The concentration of that goes up. Now let's look at our concentration of hydrogen iodide. Okay, let's kind of do what we did last time. Here's our beginning, our before we do anything. I dumped a whole bunch of extra in. It goes way up. That's during the shift, right? During that stressor. It's going to come back down, but it can't come all the way back down. So when I'm all done and I've reached my new equilibrium point compared to where I started, this is a slight increase. No, you do not have to be, sketching that out every time. I'm just doing it on a couple so you get the hang of it. Okay. All right. Next, this time let's have the stressor be taking something away. Let's decrease the concentration of hydrogen. This time we are decreasing a product. If I take some of this away, I'm going to have to make more of it. In order to make more of it, I need to shift and proceed to the right. So let's look at how things change. Well, if I'm shifting to the right, my concentration of carbon dioxide is going to go up because I'm making more of it. My concentration of carbon monoxide, as I proceed to the right, I'm using up everything on this side, so this is going to decrease. Same with the concentration of that water vapor. It's going to decrease. Now let's think about our concentration of H2. This time, I'm starting up here, right? So before we start, we're way up here. I'm going to take a bunch away. The reaction is going to shift to try to fix it. It's going to go back up, but it can't go all the way back up, right? When we're all finished, compared to where we started, this time we have a slight decrease. Okay. Let's look at the next one. This time, let's do something a little different. This time, let's increase the total pressure. So a little bit different. So when we are going to change the pressure, we need to count the moles on each side. So if I look at this, on this side on the left, I have 3 moles. On the right, I only have 2 moles. So if I've raised the pressure, I need to go to the side that has fewer moles so that the particles do not feel so crowded. So I'm going to proceed and shift to the right. Now, let's think about how the number of moles changed. Well, if I proceed to the right and I start combining some of these together to make this over here, the number of moles decreased, didn't it? If I'm going to look at my concentration of SO3, when I proceed to the right, that concentration will increase. The concentration of SO2 and the concentration of oxygen, since they're being used up, will both decrease. Now the pressure, just like before, the pressure started down low, it went way, way high, and then it came back down a little bit, but not all the way. So the pressure is going to have a slight increase from where we started. All right. Let me scroll down a little bit. For number 5, this time let's oops, that's not number 5. Okay. This time let's decrease the total pressure. Well, on this side, I have 3 moles. And on this side, I have 2 moles. If I decrease the pressure, I need to proceed in the direction that would create more particles, more moles of gas. So I'm going to need to go in the backwards direction. I'm going to need to go to the left. So if I'm going to the left, my concentration of oxygen is going to increase. I'm making more of it. In order to make more of it, this is going to decrease. The number of moles is going to increase this time. And the pressure change is going to be a slight decrease, right? It can't go back to where it started, but it can get closer. All right, number 6, this time, let's increase the H2O2. This is kind of a tricky question. There is going to be no change. That seems weird, right? People are like, wait a second, why is there no change? Because of this right here. That is a liquid. There's no change in concentration for a liquid. Liquids don't have concentration. You can't change the concentration of something that doesn't have a concentration. Yes, I added more quantity of it. Yes, I can make more products, quantity-wise, but the ratios of all of our chemicals will not be changing. So over here, we literally say, you could just write NC, which means no change. All right, let's do this one. This time I'm going to ask you to add argon gas. Remember, when pressure changes based on the chemicals that are involved in the chemical reaction, things change. But if you're changing the overall pressure by just adding an extra gas, your partial pressures don't change. You're not changing the ratios of the reactants or products to each other. So nothing changes. And the reason there is because argon is an inert gas. Right? It's not participating in the reaction. Changing it doesn't change anything. All right, the last one here, the stressor we're going to do is going to be to increase the temperature. So I need to think about this right here. That negative sign tells me that this is exothermic. Therefore, the energy is a product, isn't it? So really, it's over here. So if I raise the temperature, I need to proceed in whichever direction will use up that extra energy. That will help the temperature go back down. So if the energy is over here on the right, I'm going to proceed to the left, right? I'm going to proceed away from it. I'm going to proceed to the left-hand side. The backwards reaction is going to happen more. If I'm going to the left, my concentration of CH4 and of O2 are going to increase. My concentration of CO2 and H2O are going to decrease. The temperature change is going to have a slight increase. Just like all of our other stressors. We can't go back to where we started, but at least that temperature will be a little bit lower than when it was at its worst point. Okay. I'm just going to write a little reminder down here that if delta H equals negative, it's exo. If it's positive, it's endo. This would be the product side. This would be on the reactant side. Right? Okay. So hopefully having a few examples here shows you kind of how we go about doing this. You first have to look to see where the stressor is being, affecting the reaction, which side. Then you decide if you're going to shift left or right. Then you can start looking to see if things increase or decrease. Okay? All right, everybody. That was the last part of that Le Chatelier's lecture. I hope that was helpful. Bye.